This video provides a brief demonstration of our model generation procedure. It begins with a part library that's been deposited into an instance of SynBioHub, encoded using SBOL. Using this part library, we can then fetch these parts into sequence editing tools such as SBOL Designer or genetic design automation tools such as Cello. These tools can then construct DNA-level designs. Once those designs are constructed, we can then fetch additional information such as the proteins produced by these circuits and what those proteins interact with. This information would also be found in the SynBioHub instance. Using this information, we can construct a kinetic model encoded using the System Biology Markup Language, or SBML. Using this SBML model, we can then import it into tools such as the iBioSim simulator to do ODE and stochastic simulation. So as I mentioned, we first begin with a part library, such as this yeast part library from the Voigt lab. We'll have information about this part, such as its response function, flow cytometry, and toxicity data. You can select one of these parts to get further information, such as what the part is used in. And this particular part is used to produce the laxA protein. We can then go to the iBioSim tool and build two genetic NOR gates using these yeast gates. So here's the first genetic NOR gate, and here's the second one. We now want to create a computational model for these two NOR gates within a larger circuit. We can select the two NOR gates and select Generate Model. We want to give a name to the generated model. We'll call that NOR3. And then we want to select which SynBioHub instance has information about this part library. It's now fetching that information to build a model in SBML. Here we have the model of the first NOR gate, which has two repressors and one protein produced, and the second NOR gate, which also has two repressors and one protein produced. And finally, the composite three-input NOR gate, which is composed of these two NOR gates in series. Now we want to simulate this three-input NOR gate, and we do that by instantiating that into an environmental model that has SBML events to stimulate the inputs. So we instantiate this NOR3 into the larger design. We then need to connect it up to the inputs, and finally the output. We then can save that and perform a simulation using Gillespie's stochastic simulation algorithm. Once we've simulated it, we can look at the waveform we get and see whether that's what we intended. At this point, if we're happy with it, we can upload the final design using a combined archive to SynBioHub. So I select what instance I want to upload to. I want to put it into a new collection called NOR3. Provide some metadata about the design. Upload the design. Then we can go back to SynBioHub, select submissions, find the submission that I've just uploaded. We can then find the simulation plots that we generated that have been uploaded. So here's the simulation plot. We then have a provenance activity that indicates how did we generate this plot, so all the information is captured. You select that, it says it's generated by iBioSim using a particular simulation method encoded in this plan, and it used this environmental model. This environmental model used my NOR3. My NOR3 was composed of two NOR modules. If I select one of those NOR modules, I can then go in and find the actual gate. And that concludes my demo.